It is often helpful to be able to measure how long a segment of code takes to run. One reason for wanting to know might be that you have two or more ways of coding up the same task, and you'd like to know which one is faster. Another reason might be that you have a large data set, and you'd like to have a sense ahead of time how long it might take to run your code. You could do this by running the code for smaller datasets first, time the running time, and then extrapolate from there to the running time for the whole dataset. A simple way to measure time in Python is to use the time module. We will import the module by saying import time. One of the most useful functions in the time module is the time.clock function. That gives us the current time. We can capture that in a variable called start time. So we just type start time equals time.clock. And then we can run this again to extract the end time. I'm going to call that end time. So end time equals time.clock. If I want to see how much time has elapsed between these two time points, I can take my end time, and from that I will subtract my start time. There are a few different ways to measure time in Python, and each of them has its uses, but for many purposes, such as comparing performance, time.clock is the right function to use. Working with our previous example, the one that relied only on pure Python, I have the code here in front of me. In order to time its performance, I'm first going to catch the start time by saying start time equals time.clock. The code will run, and once it's finished, I want to capture the end time. So I capture time here again. And then what I'd like to do is print the difference between end time and start time. Let's try running this code. In this case, we might expect this to take somewhere between 5 seconds and perhaps up to 1 minute, depending on the speed of your computer. Let's then look at the second implementation of this example, the one that relies on NumPy. Again, we will capture start time, and we'll do the same once the code has run. In this case, we just have 2 lines for the code. And in the end, we just want to print out the difference between end time and start time. We would expect this code to run much faster because it makes use of NumPy. In this case, the code runs almost immediately. Let's look at the difference in performance between these two different ways of implementing the same example. I'm going to take the time I got from the first example, the pure Python implementation, and I will then divide that by the time I got using NumPy. In this case, we see that the NumPy implementation is over 80 times faster than the Python-based implementation.